So hello guys and welcome to a new video. So as you can see, it's raining outside. It's just a dull weather, so I'm gonna cheer myself up by doing a new video on the integer part. Well, let's do it. So I would like to show here that the integer part of x plus n is equal to the integer part of x plus n, where x is a real number and n is an integer. So what this equality means is that if n here, so if n is an integer, then n can be moved out of the square brackets without changing the equality sign here. So by moving the integer n outside the brackets, the equality still holds. So I remind you that the integer part of x is the greatest integer less than or equal to x, which can be expressed mathematically by this double inequality. Okay, so let's get on to the proof now. So proving this equality is equivalent to proving two inequalities, namely this one and that one. So remember that if a is less than b and at the same time b less than a, then a and b has to be equal. So this is how we are going to do it. So if we start with the first one, so by the definition of the greatest integer function, so we can write that the greatest integer, the integer part of x plus 1 is less than or equal to x plus n. And this means that by moving n to the left hand side, I get that the integer part of x plus n minus n is less than or equal to x. But remember that the difference of two integers is still an integer. So on the left hand side I have an integer less than or equal to x, and by definition this integer is less than or equal to the integer part of x. And moving back n to the right now, we get the first inequality proven. So now to the second inequality. So by definition, the integer part of x is less than or equal to x. And now by adding an integer to both sides of the inequality, so we get the integer part of x plus n is less than or equal x plus n. But once again, the left hand side is an integer, and this integer is less than or equal to x plus n. And by the definition of the integer part, so the integer part of x plus n is less than or equal to the integer part of x plus n. Now we have proven 1 and 2, and together they imply the equality. Alright, so thanks again and see you in the next video. Bye bye.